Okay, so yesterday we talked about standard deviation. How far a data point was one standard deviation away from the mean, 2 standard deviations away from the mean, and 3 standard deviations away from the mean. So today what we want to ask ourselves is, how do we compare 2 data points that are not specifically on one of these standard deviation points exactly? And what we need to do that is a z-score. So today we're going to calculate and compare z-scores. So a z-score tells you how many standard deviations a data value, that point we were talking about, is away from the mean. So how far are you away from the average value? If a z-score is positive, the data will fall above the mean. And if a z-score is negative, then the data will fall below the mean. Okay, so calculating a z-score, we need to introduce some new variables. So we have this formula, okay? Z equals x minus mu over sigma. So what are these things? All right, first of all, z is what we're trying to find, the z-score. X is the data value that we want to compare. And mu is the actual mean. So this is mu, and it is the mean. And this character right here is called sigma. Let's write that down so we don't forget it. Sigma is the standard deviation for the particular data set that we're talking about. Okay, so using these 4 variables, we're going to be able to calculate a z-score. Let's do an example. Okay, and this works for a normal curve. The weights of newborn boys are normally distributed. So we have a normal curve, just like pictured above, with a mean of 7.5. So, and that's with a mean of 7.5. Now, mean is going to be that mu character. So let's put a mu above that, and a standard deviation of 1.25. So let's put a sigma character, so we remember sigma of 1.25 pounds. So Mrs. Kraft's son Johnny weighed 9.125 pounds when he was born. So what is that? That is our x value. So that's our x value. What was his z-score? Okay, let's calculate that. So we know that the z-score equals x minus mu over sigma. So let's just plug that in. Well, Johnny was 9.125 pounds minus the mean of 7.5 divided by the standard deviation, right? That's sigma of 1.25 pounds. So when I put these values into my calculator, and you guys can do that at home, you get 1.3. So what does that mean? That's a positive number, by the way. So that means that Johnny was 1.3, his z-score is 1.3, so he was 1.3 standard deviations away from the average birth weight. That's what his z-score means. He is 1.3 above the mean. Okay? All right, let's do it again. So, some more people we know. Friendly faces. Mrs. Broccolino's son, Michael, weighed 8.1 pounds when he was born. What was his z-score? So, z equals 8.1, that's the x, minus 7.5, that's the mean, over 1.25. Not a hard calculation. Put that in your calculator, and what do you get? Well, you get 0.48. So what does that tell you? That tells you that Michael has a lower z-score than Johnny, and that his birth weight was 0.48 standard deviations above, because this is positive, above the mean. Okay. All right, let's do it one more time. We have Mrs. Kraft's nephew. So Joey, He weighed 1.5 pounds at birth. What was his z-score? Well, z equals 1.5 minus 7.5 over the sigma, same sigma, 1.25. Well, when you calculate that, you get a negative 4.8. What does that tell you? That tells you that Joey's birth weight was 4.8 standard deviations below the mean. Now, we don't generally talk about standard deviations that are more than 3 standard deviations below the mean. You can see from our charts that we've done, we usually talk about the first, the second, the third standard deviations. What does that tell us? That tells us that this baby was extraordinarily below the average. Below the average. He was extraordinarily below the average. Okay, and it's true, he was a preemie, born at 26 weeks. So he was extraordinarily below the average. Put that extraordinarily below the average. Okay, so sometimes those things happen. We just have to think about what might the case be in this kind of situation where we're so off the chart. Joey was way to the left. He is in the 0.003% category, way down on the left there. He's way down to the left. Okay? All right, so whose weight is more unusual? Let's talk between Johnny and Michael. Okay? Between Johnny and Michael, whose weight was more unusual? Well, Johnny was 1.3 standard deviation, a z-score, and Michael had a 0.48 z-score. So, who was more unusual? Well, Johnny. Because Johnny was farther from the mean. Okay? And that's what makes Johnny's score more unusual. He was 1.3 standard deviations away from the mean. And that's what you do with z-scores.